Great. Thank you, everybody, for showing up for the monthly community meeting. We have many news today. This is our current team. Just reminding the mission for the Lean Flow, right? This is the monthly community meeting where the Lean Flow is leading the meeting. The main mission of the Flow is to improve Lean in key areas about scalability, usability, documentation, improve automation. We want to support many different areas, of course, for mathematics, but also software hardware verification, AI for math and code synthesis, and education, right? One of the main goals of the Lean Flow is to achieve self-sustainability. Now, we have a 5-year mission, but now we have 4 years and 4 months left. Our roadmap is publicly available. These slides are on Zulip. We share them on Zulip. We share them there because there are many links you can follow in our slides. But what we're here is a big picture of what we are building at the Lean Flow. We have Lean, right? We have 2 main components there that we break Lean in 2 main parts: the front ends and the back ends. The front end, we have the parser, macro system, static, interpreter, elaborator, and LSP server, right? In the back end, we have code generation, termination checker, proof automation, and the kernel, right? We have many different people working these 2 components, subcomponents of Lean. We have Lake and Reservoir, our package registry. We have to maintain the VS Code plugin and develop it, add new features. We have Verso, the documentation authoring system, and we are using it to build our websites and the reference manual. But David is working with many people in the community for them to switch their documentation to Verso, right? We also maintain the Lugo library search tool, right? And 2 packages, the standards library and the LeanSat package. The standards library now is in the core repository. In LeanSat, we're discussing whether we're going to also include it in the core repository or not in the future. And when we distribute Lean, distribute with all these packages pre-installed and pre-compiled for your platform. And many news since our last community meeting, led by the Flow. We have released 4.0. There are so many improvements there. If you follow the link, you're going to find a huge list of new features, improvements, and bug fixes. We have a blog post where David summarizes many new cool features there. We have a next release candidate, 4.8, release candidate 1. Thanks a lot for all the feedback you have provided. The release candidate 2 is coming soon. And you can see which PRs are going to be included in RC2 that's addressing specific issues reported by the community. Marcus Himmel joined the Lean Flow. This is awesome. Many of you know Marcus because he's also a Mathlib maintainer. Joe Hendricks moved to AWS. Another big change that we're going to talk more about it is that the package STG4 moved to Lean Improver community and is now called Batteries. We have a slide to talk about that. There are also 2 applications in software verification. AWS Clean Rooms, differential privacies using SampCert, developed by John Tristan. I think he's here today. Is a proven correct sampler implementation developed using Lean at AWS. Another one is this blog post, Lean into Verified Software Developments by the Cedar team, explaining how they use Lean in their projects. It's a really nice read. We have some statistics since the last meeting we were leading in March, right? Since then, we had 78 issues have been closed. We have 67 new ones, 48 of them were closed. We merged 358 commits in Lean. We had more than 374 PRs that had been created, and 331 of them were closed, right? Were merged or discarded, but we reached a conclusion about for them, right? Now let's focus a little bit on the move from SDG4 to batteries. The new standards library is in the core repository. It's going to be distributed with Lean from now on. SDG is also going to be using the cathedral development model and is going to be managed by the flow, right? Batteries is still using the Bazaar development model. If you want to understand cathedral versus Bazaar, I put a link there, and it's still managed by the community. The scope of the new standards library are basic types and theorems about them, async support for async I/O, networking, internet protocols, regular expressions. That's the scope we are planning for the standards library. The goals are coherence with, we want it to match the vision for the language, no gaps. I mean, even if there is a gap, there is in the roadmap something to eliminate the gap. Core behavior is not overridden. This is going to be forbidden in the standards library. Of course, Lean is extensible in batteries, in any other package, people can override the behavior of the system, right? But in the standards library, you get what the designers plan the language should be, right? And the scope also is similar to the Rust standards library as an inspiration. There are many improvements to the VS Code extension. For example, we are going to find a restart file button in the ends. It makes it really easy for people to restart the file, the server on the file. Now we have a go-to definition when you're hovering over symbols in the info view. We had a shortcut, but I always forgot the shortcut. I was complaining, and now we have the link that is very easy. I love this link. I use it all the time. When in the info view, I want to jump to the definition of a symbol. I use this menu option all the time. There's multi-tool chain support now. I mean, if you have two projects open with different tool chains, they can be used at the same time, right? Here's a demo that's Mark created showing what's going on, right? So you have 4.7 and 4.8 release candidate 1 running the same session of VS Code, right? Nest projects are not supported yet, but this feature here is already super cool. This a topic that we are covering is better support for diagnostics. In VS Code, we have better support now. When something weird happens, there's more warnings, error messages when setup issues are detected, and a new command for collecting information about the user setup. This is super useful. You're going to see that better diagnostics is a common topic, was a common topic for us. There are many bug fixes. The first one, I love the first one. I mean, this one was driving me crazy. The semantic highlighting was sometimes stale, and I never understood what was going on. It's great that Mark fixed it. This is amazing. Go to definition, jump to the correct definition when name clashes globally. Also, this one is a minor annoyance, but it's great that it has been fixed. And this one that many people complain about, that Lean would try to autocomplete things, keywords like with, right? And this doesn't happen anymore, right? We have now the nightly, the live Lean.lang now, the interactive version on your website, that's on your web browser, that runs Lean on your web browser now. You can use the nightly and stable releases there. You can select which one you want to use by clicking this symbol here. When you click it, you go to settings, and you can select the Lean version, right? The latest version with Mathlib, the latest stable release without Mathlib, nightly. We're even discussing about how can we include, how to make it easy for make it convenient for releasing Mathlib for also the stable release in the nightly. Going back to diagnostics, right? We have now a new command, set that a new option, diagnostics true, right? Many error messages are going to mention this option, right? And if you put here, for example, he'll show you which declarations have been unfolded, right? You can quickly see the to-add subgroup is being unfolded a lot in this example. Everything's collapsible. It doesn't overwhelm you the amounts of information. You can control the thresholds. For example, if you put here 100, it will surpass set range and VS orbit. And it helps us to diagnose issues, right? And we are going to see that we have commands to address this kind of issue. It also helps us detect, for example, problems with SIMP. For example, suppose that you define two theorems, one that says that f of x should be rewritten in g of x, and sometimes in a completely different file, you are saying that g of x should be rewritten as f of x, creating a loop, right? And now when you use SIMP option diagnostics, you're going to get diagnostics for SIMP, saying how many times each theorem has been tried, how many times it has been used, and you can disable the problematic theorems, right? We found in the library theorems that were applied everywhere was just overheads, and we removed the notation from them. Everything you can hover, all these statistics, you can hover over them, the symbol, you can jump to the definition, you can visualize the type, helps you to diagnose problems. For type class resolution, also you get in Lean, when you're solving a type class resolution, you may have to perform unification. When you perform unification, sometimes you have to solve pending type class resolution problems, and this creates a loop. You can have nested unifications inside of type class resolutions and type classes inside of unification problems, creating a recursion. And we have now options controlling how deep you want to go, right? And whenever you reach the limits, we save instances that have not been tried because the limit has been reached, right? And you can increase the limits. The message tells you how to increase the limits. Of course, as you increase the limits, the computation Lean is going to do more work, but you get more precision, right? And this addresses many issues people were having in MathLib. There's also a PR for fixing a type class caching issue that was creating some counterintuitive behavior in some MathLib files. And we also have commands for sealing declarations, right? So you can say, for example, seal add subgroup.op and set in this theorem, right? Basically, Lean is going to treat them as opaque constants, right? Or using another terminology, irreducible. They're not going to be reduced during unification, right? And this can speed up a lot some problems. You can collect statistics about which declarations are being reduced and folded by Lean, and you can seal them. You get sometimes a huge performance speed up, right? We have also profiling tools, right? You can use Trace Profiler, and you can get information about which parts of Lean are bottlenecks, right? We have also the Trace Profiler user heartbeats, and you can visualize the outputs using the profiler from Firefox. Right? It's useful, especially for people that are developing their own tactics. Right? If they want to understand why their tactics are slow, or maybe it's because my tactic is using SIMP, or the initial equality tests are consuming too much time. You can get all this information by using this new option. And if you're a very advanced user, Lean user, even if you're not developing tactics, this may still be useful for you. One thing that the community was asking a lot is shorter instance names, right? This was quite tricky. It's conceptually a simple problem, but actually to fix what was quite a challenge because we want names that can be used by users. You want to avoid clashes because these names automatically generated. We don't want two different files creating different things with the same name, and we want the names to be short, right? And Kyle figured out a new way to create the names that is way better, right? Here's the histogram showing here showing the old implementation. We had names with more than 1,000 characters, and now it's below 100, right? You see, it's way better than new names. This was driving the community crazy in some cases, especially files cheap inside of Mathlib. You'd find monstrosities like this one. This was the name, a name of an old instance we had in Mathlib. LeanSet now has a verified bit blaster. It's not complete yet, but it already you can already use it. It supports all bitwise operations, addition, and it's using the set solver behind the scenes that produce a LRAT proof, and we have a verified LRAT proof checker in Lean, and you call BV decides, and it's going to do all the transformation to sets that has been proved correct, then calls the set solver, gets a LRAT certificate, it's checked with the verified checker. One caveat here is that the LRAT checker is being executed. We're running it as native code. So when you use BV decides, the Lean compiler, the code generator, is now part of your trusted code base. But this is fine for many users. Of course, you have to. If you ask the team for the dependencies, you are going to get. You're going to get this extra dependency that's is assigned to you that you are now, your trust code base now includes the Lean code generator. Vercel now has incremental elaboration, right? So you're going to see the yellow bar showing progress as you're processing Vercel files. This is also a great demonstration that a non-Lean GSL can also support incrementality, right? How to achieve that, you can look at how Vercel did it, right? Another really cool feature that's coming in 4.9, but Sebastian just posted the incrementality call for testing on Zulip, right? This is really cool, right? I mean, you see here what's going on, right? You're checking the file. Usually, whenever you are editing a theorem, you start processing from the beginning of the theorem. Now it's starting from where you changed it, right? You can see in this demo the orange bar, right? You are not starting from the beginning for every single change. Of course, some changes will force you to start from the beginning, but for many of them, you get instantaneous feedback now. And probably there are some corner cases that are producing weird behavior and would really, if you're willing to help us testing this feature, would be great. Please go there and follow this link to figure out how to use the tool chain that gives you this new feature. Another feature that people are asking a lot is TOML files for Lake. It's there. It's some packages are already using, right? AZOP and Postgraph are already using the TOML files, and the goal is to make sure this is powerful enough to support even Mathlib, right? This has been active for the community. This is also useful for when integrating Lake into other build systems like Bazel from Google, right? We're super excited about this feature, right? And it's going to be much easier for people to build tools that process these files, right? There's a Lake build refactor. There's substantial changes in the release candidates. there's some problems, but they're going to be fixed in RC2. But one cool feature now that's if you're in the terminal, you now don't get a list of things, messages. You keep the same message, keeps updating like a modern build system. Another cool feature is wfail that causes Lean build to fail if a job logs a warning, right? Here is a list what we are working on this quarter, right? In the package management, we're making the final touches to Reservoir, adding lake supports to it. The cool idea is that you're going to be able to, in your lake projects, just say the name of the package and use Reservoir as the registry, right? We're going to continue performing lake critical fixes and improving the TOML file and start working on the cloud cache support. We're performing final touches on Verso. David is going to start working on the reference manual and also helping the community porting existing documentation to Verso, right? So mathematics in Lean. David is working with Patrick Massot and Jeremy Avgad to get mathematics in Lean ported to Verso. In the front end, there are many elaboration critical fixes. The incremental tactics are coming. Also, more parallelism when we're elaborating your files, and the module system design, right? The module system, I think, is a feature that many developers are excited about, people that use Lean as a programming language. But we also expect the module system will allow Mathlib to compile way more efficiently in the future, right? In the backends, we're going to start working on SMT-like automation, congruence closure, rematching, case analysis, integrating Omega into this loop. We're already working on the bit vector solver, add support for mutual structural recursion, and also we are aligning the elimination principles that are now being generated with the equation theorems. The idea is that we want them to, the behavior of the equation theorems to match exactly the elimination principles, or at least be very, very clear to users how to combine both and transform sometimes big proofs in one-liners, right? By having these two features well aligned. The Visual Studio Code plugin is still some improving usability, critical fixes. We are always trying to make the installation more user-friendly. We're adding critical missing features in the LSP server. The standards library, working on the roadmap for the standards library this quarter. Hash maps, red-black trees, raising list theorems, right, to make sure they are complete, right? And have some web server fundamentals there. For AI ML, we want to have integration of VS Code. We want to make it really easy for people to plug in their models to Lean, but to have the auto-completion, all these features available out of the box. You just say which model you want to use and you get this integration. We are working with more to have our LLM fine-tuned for Lean that we want to serve to the community, make it really easy for everybody to use it. And Kim's working on is improving REPL, right? And even potentially providing a Python package that makes it really easy to use REPL. Many of you have used REPL to control Lean. There are many users using it. It's a great way to control Lean using JSON messages. This is basically what we're going to be doing this quarter, what we're already doing, and now we have plenty of time for questions. We're going to stop the recording, and we know that some people are not comfortable asking questions while we're recording.
Yeah, I think last time we said we could record the first questions and then at the end leave time for unrecorded questions. Do I remember that correctly?
Yeah, maybe. Yeah, let's do it.
I think some people are in favor of recording at least some of the questions.
Okay. Any questions while we're still recording? The code owners are, yes, is the LeanFlow. The LeanFlow is responsible. The other code owners, and they are going to be responsible for maintaining. If there's a gap, a bug, it will be in the issue tracker of the main repo, and the LeanFlow is responsible for these fixes. Sorry, I didn't repeat the question. It was, who are the code owners for the components of the newest standards library?
Do you know who specifically in the Pro would be involved?
Yeah, it's going to be Marcus is going to be involved. Eventually, other people in the Pro team is of course involved. Henrik in the future will be involved, and we're hiring more people. Any other questions? Let's switch to stop recording. Okay, I will stop now.